Hey guys, welcome to question MM440 of the Maths Methods Fortify study guide. So in this question, we've got Jordan, who's a farmer, and he owns two paddocks, paddock A and paddock B. He uses different types of fertilizer in each of them to test which one produces longer grass for his cows. The length of a blade of grass in paddock A, x centimeters, so this is our A, is a continuous random variable given by the probability density function negative pi cos of pi x on 30 over A, between 15 and 30. Awesome, and 0 elsewhere, as always. Awesome. Now, part A, which is a 2-mark question, says show that the value of A is equal to 30. All right, awesome. So first of all, we need to recognize that because this is a continuous density function, or probability density function, the area under this graph is going to need to be equal to 1, right? So that's the whole principle of a continuous density function. So what we're going to do is we're going to say that the area under this graph is equal to 1. So if the area is equal to 1, that means that our area is the integral from our lower to our upper bound, so from 15 to 30 of this. So negative pi cos of pi x on 30 over A dx, of course. And what does this equal? 1, right? So the area is 1, so this has to all equal 1. Now, what I'm going to do is I'm going to take negative pi on A out as a common factor, or just a factor in general, because it's a constant, and we can do that. And it'll be a bit easier to integrate this without that in there. Awesome. So now what can we do? We can actually integrate this normally. So we get negative pi on A out the front, and then that's outside of the integral of this bit here, which happens to be 30 sine of pi x on 30 over pi. Awesome, because we change cos to sine, and then we do 1 over the coefficient of x, so we end up with this here. Now this is a CAS question, so you can do this in your calculator, but you still do need to show all this working. And that's from 15 to 30. That's our first mark. So there we've got our 1 mark. And now what we can do is actually just evaluate this as we go. So negative pi on A still out the front. And what we're going to do is we're going to sub in our 30, and then we're going to minus sub in our 15. So 30 sine of pi times 30 over 30 is just pi. So we get 30 pi on 30 over pi minus 30 sine of 15 pi on 30 over pi. It's a minus there. Awesome. Sweet. So then we can go and evaluate all this. What we get is negative pi on A outside of sine of 30 pi on 30 is the same as sine of pi, and sine of pi is equal to 0. So this whole thing here is equal to 0. Minus 30 times sine of 15 pi on 30, which is the same as pi on 2. Sine of pi on 2 is simply 1. Okay, so we get 30 times 1 over pi. And then, where's my rubber? Actually, there we go. So I'm just going to take that away and get rid of all this. Awesome. Which means that we have our 1, which is our area, negative pi on A, multiplied by 30, or negative 30, I should say, negative 30 over pi. Okay, so what we get is 30 pi over A pi. Our pi's can cancel, and we get 30 over A equal to 1. So therefore, A equals 30. This is our second and final mark, guys, for part A. If you have any questions about it, as always, let me know. But for now, let's move on to part B. Part B is a 1-mark question, and says, what is the probability that any given blade of grass is between 20 centimeters and 25 centimeters long, correct to 4 decimal places? Awesome. So this is simply a 1-mark question, which means we can just do this in our CAS because we've got it available to us. So now that we've found what A is, we know that that's equal to 30 there. So I'm going to just change that. And if we need to find the probability of it being between 20 and 25 centimeters, what we're actually finding is the area between those two numbers, okay? So the probability that x is between 20 and 25 is equal to the area from 20 to 25 of f of x, right? Where our f of x is this. So therefore our probability is equal to 20 from 20 to 25, the integral of negative pi cos of pi x on 30 over 30 dx. And because this is a 1 mark question, guys, I would simply just sub this straight into my CAS. And what you'll get is 0.3660, which is correct to 4 decimal places. This is our first and final mark for part B, guys. So let's move on to part C. Part C is a 2 mark question again. And it says, Jordan picks a blade of grass from paddock A and notices that it is longer than 20 centimeters. What is the probability that it is shorter than 25 centimeters? Give your answer correct to 4 decimal places. Awesome. So essentially what we're saying is, what's the probability that it's shorter than 25 centimeters? But we know that it's longer than 20 centimeters, right? So given that it's greater than 20, right? So because it tells us in the question, that was horrible, sorry. Because it tells us in the question, he picks a blade of grass and notices that it is longer than 20 centimeters, we're dealing with a given that formula, okay? So according to our given formula, which is probability of A given B, this is equal to probability of A intersect B over the probability of B, which means that this is equal to the probability that X is less than 25 intersect X is greater than 20 over probability that X is greater than 20. Awesome. So what that means is, we're actually trying to find the probability between 20 and 25, so from 20 to 25. And you can include these as well, it doesn't matter either way with continuous, it's all the same, over the probability that X is greater than 20. Awesome. This is our first mark, recognizing that. So we've already found the probability that X lies between 20 and 25, right? We just did that in the previous question. So this bit here is equal to 0.3660. That was the answer to our part B. But now we need to figure out what this is. So the probability that X is greater than 20 is all the area above 20 under the graph, right? So the integral, so the area from 20 to our upper bound, 30, right? Because we're talking about everything above 20, so 30 is our upper limit, of negative pi cos pi x on 30 dx. Oh, sorry, over 30, and dx there. Sweet. Cool, and then plugging this into our CAS, we get 0.8660, which is pretty cool. And then from there we know this and we know this, so now we can sub in that whole thing. So we can say that this bit here is equal to our between 20 and 25, which is 0.3660, and our above 20, which is 0.8660. It's a pretty funny coincidence that they both end in 660. That's cool. All right, so putting this into our CAS, we get 0.4226. This is our second and final mark for part C, guys. If you have any questions, as always, let me know, but let's move on to part D. Part D, again, is a 2 mark question. I'm just going to get rid of all this. And it says, what is the median length of grass in paddock A? Awesome. So whenever we deal with medians in continuous probability density functions, what we're saying is that half of the data lies on either side of this particular median. So what we're saying is, if we had a graph that looks something like this, and our median, this point M, is the point where 0.5 of the data is on this side and 0.5 of the data is on this side. So what we're going to need to do is solve an equation that says that our area is equal to 1/2 or 0.5, depending, it doesn't matter either way, from our lower bound 15 to our median, which in this case we're going to call M, right? So this is our function again, because we're still dealing with the same function. Awesome. And then from there, all we need to do is just solve for M, right? Because we've got this side, we just have an unknown M that we need to solve for. So from here, what we're going to do is I'm going to take out negative pi on 30 as a factor out the front because it's a constant. So we get 1/2 equals negative pi on 30 outside of 15 to M cos of pi x on 30 dx. Just coming up here, what we get is still just 1/2 on this side. Going to leave the negative pi on 30 out the front for now. And all we're going to do is just then integrate this. So what we get is 30 sine of pi x on 30 over 30 from 15 to M. And then we're just going to sub this in and try and solve for M. So we get negative pi on 30, 30 sine of pi m, right? Because we're subbing in our m for our x. So we get pi m on 30 over 30 minus 30 sine of pi times 15 over 30 over 30. And that's our equation. So this is our first mark, guys, getting that. Now we can just keep going with this. So we get negative pi on 30. We can just keep this how it is. So 30 sine of pi m on 30 over 30. Now for this bit, we know that pi times 15 over 30 is the same as 15 pi on 30, which is the same as pi on 2. Okay, so sine of pi on 2 is just 1, which means we get take away, actually, sorry, this was pi, not 30, my bad. So pi. You probably picked that up quicker than I did, so apologies for that. And we get 15 pi on 30 is the same as pi on 2, which is 1. So sine of pi on 2 is 1. So we get take away 30 times 1, which is just 30, over pi. Awesome. So then simplifying this, we can multiply our 30 into this. We can also multiply our pi. So the pi on 30, this pi and this pi cancel, and so does that one, and then this 30, 30, 30 cancels out as well. So what we end up with is negative sine of pi m on 30 plus 1, because we've got negative 1 here minus that, so 1/2. And then we can solve for m here. So I would actually just sub this straight into my CAS. You can do it by hand, but at this point we've shown a fair bit of working. So solve for m in CAS. M is equal to 25 since m has to be between 15 and 30, right? Because x is between 15 and 30, so m has to be that as well. So guys, m is 25, so therefore our median is equal to 25 centimeters. And this is our second and final answer, guys. Please make sure that you include your units, because otherwise you're going to be incorrect. But that's it for part D, guys. Let's move on to part E. Now in part E, we're going to be moving over to our other paddock. So paddock B, I'm just going to rub all of this out because we don't need it anymore. And part EI is a 2-mark question. Awesome. So it says the grass in paddock B is a little different, where the length of any given blade of grass, y centimeters, is a normally distributed random variable with mean 25 and standard deviation 3. Question I says, let Z be a continuous random variable which follows the standard normal distribution. Determine the value of K where the probability that Y is less than 29.4 equals the probability that Z is greater than K. Cool. So what we're dealing with here is normal distribution, as you're aware. So let's just quickly draw one of these normal distribution curves, because that's going to help us deal with this a little bit. Now we know that our mean is 25 and our standard deviation is 3. Okay, so we have 28, 31, 34, 22, 19, 16. Now these are our x values, or actually in this case our y values, right? These are the lengths of the grass blades. Now Z is our standard normal distribution, which in our case, or in every case, is how many standard deviations away we are from the mean, right? So at our mean, we're 0 standard deviations away from the mean. Then we go up 1, 2, 3. So these all correspond to each other. And then -1, -2, -3. Awesome. So now we actually need to figure out what we're trying to find. So we're looking at the probability that y is less than 29.4. So 29.4 is, I don't know, somewhere here. And we're looking at all the probability here, which is all of this area. And we're saying that this area here is equal to the probability that z is greater than k. Okay, so our k value is going to be one of our z values because we're dealing with z. And we're dealing with the opposite sign. So here we're talking about less than, here we're talking about greater than, which means the probability that z is greater than k is going to be somewhere here. Right? Because everything from here onwards is the same as everything from here upwards, right? And we need to find our corresponding y value, which will allow us to find our z value. So, what do? Well, we've got this little magical formula that corresponds our z values to our x values, right? Or in our case, our y values. So we know that z is equal to x minus the mean over the standard deviation. We know that our x value in this case is 29.4. We know that our y value, I should say, we know that our mean is 25, and we know that our standard deviation is 3. Okay. Now, putting this into our CAS, what we get is 1.47, which means that here, our z value corresponding is 1.47, which makes sense. It's halfway between 1 and 2-ish. Now, this is all well and good, but we actually want this z value. We want the z value on the opposite side, all right? So this is our first mark here. We haven't answered the full question because we still haven't found this value of k here. So we need to find this. Now, we know that because the normal distribution is symmetrical, we can actually say that if this is 1.47, this is negative 1.47. Okay, so therefore k is equal to negative 1.47. That's our second and final mark for this question, guys. If you're not too sure about how any of that worked, obviously just hit me up in the comments below. But for now, let's move on to part EII. Part EII is a 1-mark question, and it says find the value of n where the probability that z is less than, let me just get rid of this bit here, and this bit. Cool. So where probability that is less than negative k equals the probability that y is greater than n, all right? So we already know k. We know that k is equal to negative 1.47, which means that the probability that z is less than negative k is the same as the probability that z is less than negative 1.47, so positive 1.47, right? So what we're saying is we've got the probability that z is less than 1.47. So everything from this point onwards, again, like it's the same as before. But now we're trying to find our y value. So we're trying to find the y value at the point n, which is the opposite of our z, right? So here we've got z is less than, and here we've got y is greater than, right? So basically we need to find the corresponding y value at this point here, right? There's multiple ways we can do this, but we know that 29.4 was our x value before, so this is 29.4, which means that this value here has to be the same distance from the mean away, right? So this here is 4.4 away, so this distance here is 4.4, which means this distance here as well is going to be 4.4. So 25 minus 4.4 is our answer, which is equal to 20.6. So therefore n equals 20.6. This is our first and only mark for this question, guys. This is really just a logical question. You can't really do this in your CAS too much. But if you have any problems with them, obviously just let me know. Guys, let's move on to the last part of this question. Our final part of this question, part F, is a 1-mark question again. And it says 73% of the grass in paddock B is longer than y centimeters, little y. Find the value of y correct to 1 decimal place. Awesome. So we know that 73% is longer than this certain number. I'm just going to rub all this out so we can use it. So let's say that our y value is here, just for argument's sake. We know that this is our y centimeters, and 73% of the grass is longer than that. Okay, so 73% is longer than this. Now, we know the probability is 73%, and we're looking for the x value, which means we have to use our inverse normal in CAS. Okay, so inverse normal. Inverse normal is going to ask us for 3 things: area, mean, standard deviation. Now, our area is our probability, right? But we don't need to use this probability. Inverse normal always wants the area to the left of the point that you're looking at. Okay, so if this is 73%, that means that this is going to be 27%, which means that our area that we put in has to be 0.27. Mean is 25, standard deviation is 3. Putting this in our CAS, it'll spit out an answer that says y is 23.2 centimeters. Now this is to correct 1 decimal place, which is exactly what the question's asking for. And this is our first and only mark for this question, guys. And that's our final answer. So that actually wraps up MM440, guys. If you have any questions about it, as always, please hit me up in the comments below. But otherwise, thank you very much for watching, and I'll see you in the next video.